Okay, going again.
It's like a whole gap. So they're watching the video.
Okay, next rule. I don't know if I'm going to want to keep recording these. I should do it during the summer, like once formally, when no one's here, like actually make good ones and then just...
And have them up online, and then you never have to do it again.
I know. But it's not much fun. It's nice to hear these. I feel like I get to know you guys better at review sessions usually than outside of school.
Like the people who can't come to stuff, you know?
Okay, chain rule. Next rule. So, okay. Chain rule. So we have this. Aren't you in Calc? Yeah. No? Ah. I thought you were in Calc. Okay. So, what we're going to do, you're going to bring down the 5 just like last time. So, what you start with, take the derivative of this with respect to time, bring it down, then add deal with the inside. So, I brought it down, and then I take that and I lower it by 1. But then, I still have to take the derivative of the inner function. So I did the outer function, see the x to the 5th? I brought it down and lowered it. But I still have to deal with this inner function. So now take the derivative of that one too. So bring down the 2 and then lower it. Oh, 3. So if you have a function that's raised to a power, you bring down the power and rewrite the function as if it was just like an x. And then you deal with the inside after. Okay, so you do the derivative of the outside function and then the inside function. So just think of this as like an x.
But you still multiply them together.
Yes, you multiply them together. But 15, x to the 3rd, 4th, and x squared. Okay, let's try another. I probably should have started with an easier one, but that's okay. We'll do that. I should be using t's. So, what we're going to do, bring down the power, rewrite. Then take the derivative of the inside. Bring it down, lower it. Bam. Okay, now I'm going to have you do one. We pretty much did that one. Bam. Do it. That what you guys got?
Yeah.
Yay! Okay, we learned that one. It's called the chain rule.
Calculus was easy.
Now we have one more left. Yeah, it's not that bad.
I think it's closer anyway.
Trig rules. Now we have trig. Sorry. Okay, so you should know these. If my x of t was sine of t, when you take the derivative of dx with respect to t, the derivative of sine is cosine. Okay, if I start with cos, then the derivative of that is sine. But if you go sine to cos, there's no negative. If you go cos to sine, I get a negative. What? Okay. Yes. There's a negative, no, like negative sine of t. Not inverse sine, just like negative up front. Okay? If I have, let's go crazy. Let's mix this up. We're chain ruling now with trig. So I have an outer function and an inner function. So think of this as like sine of t. and first take that derivative. So the derivative of this is sine goes to cos. So ignore the inner function, just take the derivative as if it was just t. And then take the derivative of the inside and multiply that to the outside. So the derivative of 2t is just 2. You can do, because this is 2t to the first, so it would be 2t to the 0, which is just 2. So that's the chain rule with the trig rule. Crazy. Let's try another one. Bam. Take the derivative of the outside first. So dx dt, cosine goes to sine, negative sine. The inside, just think of it as a t. And then take the derivative of the inside. So bring down the 2 and do the 1. Okay, now let's look at these again.
Not that one.
Remember harmonic motion. We learned that equation. We did. We did. And then they'll ask you about the velocity from this. So if I want the velocity, what am I going to do? Take the derivative by time. So the velocity here, again, this is a constant. The constant, oh, I didn't go over that yet. The constant you just leave out front. Like if it was like, think of it like this. When I rewrote it, like when I took the derivative, I brought this down and I left the 5. I didn't have to do anything with this. It's just a constant. Okay? So here, when I'm taking the derivative, this is just a constant. It's just a. I'm taking the derivative with respect to t. So my a stays. Sine goes to what? Cosine. And then I have to chain rule the inside. The derivative of omega t would just be omega, because it'd be t to the 0, so it's just omega. And that's why my velocity was a omega, cosine. Now let's take one more to get acceleration. Remember, acceleration is the derivative of v. So, to get a, again, these now you just leave them. The cosine becomes what? Negative sine. Leave the inside. And then take the derivative of the inside. So the derivative of omega t again is just omega. So that's why a is a omega squared. Okay, now we're going to start with this. Find me V and A. Go. So take the first derivative, give me velocity, take the second derivative, give me acceleration.
I'm sorry, you're not happy.
No. Why is anyone only B? Come up for home, but. She's not a little, it's harder to hold her.
It's yellow, babe.
Okay, so then A of t would be negative A omega cos omega t times omega. Cool?
So you keep the negative.
Yeah, because I didn't get another negative. When I go from sine to cos, I didn't like get another one. I only go from cos to sine. Okay. That's really. Oh, we need special derivatives. Uh-oh, they're hard to hold and have paper in my hand. Okay, special derivatives that you just need to know. There's like 2. And I actually think they might be on the equation sheet. There's some common derivatives on the equation sheet. It's hard to focus. Sorry. The baby. Okay. Let me get rid of that.
She has to stick over here.
Yeah, she didn't finish on that.
I'm just gonna keep her entertained as much as I can. Okay, so, where's mine? Oh, special derivatives. Where did I put it? Oh, here it is. So, there's something you need to know. X is ln of t. So if I'm taking the derivative of natural log, it becomes 1 over t. That's a big one. Taking the derivative of a natural log just becomes 1 over t. I don't know why, but it's what I did. I feel like they probably taught me at some point, but I don't remember. Okay, so then the next one that you need to know. Y is e to the x. If I'm taking this with respect to x this time, I know we keep switching, but you have to be able to take it with respect to different variables. So the nice thing about this, if I'm taking this function with respect to x, it's just e to the x. It doesn't change. The only time it will change is when there's also a power rule with it. So let's try y is e to the 2x. Oh, she wants my there's cookies in here. Okay, so here, if when I take this derivative, this is the same, like it's just 2x. But then I have to invoke the power rule and take the derivative of 2x. So it's the derivative of 2x.
2.
It's 2. Okay. So the derivative of e to the x is just e to the x. It doesn't change.
I know.